Hello. So on this video, we're going to start on section 1.3 in the book. We're going to start talking about average rates of change. So let's start with the definition. The rate of change of a function f of x on an interval going from a to b, including the endpoints. And that's important. We're only going to be talking about average rates of change on intervals. And I mentioned this and I talk about this because in calculus, you're going to talk about instantaneous rate of change. Instantaneous rate of change happens at a particular input. Okay? Average rate of change happens on an interval. Okay? So rate of change of a function, and let me put in average there. So the average rate of change of a function f of x on an interval a to b is a measure of how much the function changes on average on this interval. And I'll explain the on average part better. Why do we say it's an average when I do some graphical examples? But that's what the average rate of a function on an interval is. It's just a measure of how much does the function change on that interval. Now there's a really nice formula for this. It's pretty easy to remember. So the average rate of change of f of x on the interval ab. Now here, since I don't want to write that whole sentence all of the time, I'm just going to denote that sentence by using this notation here. So capital A, subscript, whatever interval I'm finding the average rate in. So in this case, it's the interval AB. So subscript the interval AB, and then F, just to specify that we're finding the average rate of change of the function F. Okay. So this is the notation I'm going to use from now on to represent average rate of change of the function f of x on the interval AB. A subscript AB of F, right, or F. And the formula is very easy, right? Basically, on the numerator, it's a ratio. On the numerator, you have f of b minus f of a. Another way to think of it is f of the right endpoint minus f evaluated at the left endpoint of the interval, divided by the right endpoint of the interval minus the left point of the interval. Right? So f of b minus f of a divided by b minus a. Okay. And that's a very simple formula, and that's what the average value of a function is. Now, why do we call it an average value instead of just saying the value of the function on this interval? Well, first of all, it's a measure of how much is the function changing. Right? So how do you measure that? Well, you could find the total change. You can definitely do that. That's not what we're doing here. In fact, it's a little bit harder to find how much does the function change as a total amount. So counting out every single change on an interval, that's a little bit harder to do. This is not what we're doing. Right? So in a sense, that's why it's called an average rate of change, because we're not actually calculating the total change. We're assigning a quantity that on average, you could say, okay, on average, you can say that the function is changing by this much on this interval. Again, it's not the total amount, but it's an approximation. And you can see it more easier or what exactly is going on if we actually graph things, right? So first, let me introduce some symbols here. Right? So let triangle y, right? So I call it triangle, but this triangle symbol is called delta. It's the Greek letter delta. So let delta y be equal to f of b minus f of a in the definition above, and delta x be equal to b minus a. Another way to think of this is, remember that f of b and f of a are output values, right? They're values in the output set. Right? Another way to think of those values is as y values. Right? Remember that values in the output set we usually denote by the variable y. Right? So what's f of b minus f of a? That's just quantifying some change in the y-axis. Right? That's why I call it delta y or change in y. Similarly for change in x or delta x. Right? B and a are input values, so x values, we're subtracting them, so we're kind of measuring a change in x. Right? B minus a is how much do the x values change from b to a. Now, if I plot a function, so here I plotted in blue some random function f of x, right? And then what I did is I plotted f a and b, so the input values a and b. Then I found the corresponding function values. As you see that I plotted f of a and f of b, and I show you what these delta y and delta x look like. Right? So delta y, like I mentioned, is just a change in the y-axis. Right? So take f of b, subtract f of a. Right? And what you're calculating is this red interval or red symbol interval that I drew there. Right? Similarly with the x-axis, what's changing x? When you compute b minus a, you're actually computing this sort of interval that I drew down there. So you're computing two quantities, a change in y and a change in x, and you're taking the ratio of those two quantities. Right? So graphically, that's what the average rate of change is. Right? So notice, this is not the total change of the function. Right? All I'm doing is calculating the change of the function evaluated at the endpoints and divided that by the change in the inputs. Right? So we can say that it's the total change of the function, but we can kind of say that it's a sort of average, right? It's a sort of number that we can use to kind of give us an idea of how much is the function changing on this interval. Yeah. So that's what it looks like graphically. Once we talk about more about linear functions, or not, let me not say linear functions, but linear polynomials, we're going to see how this relates to slope of lines, because this is basically the slope of the secant line through 2 points, right? But I'll talk more about that later. Okay. Now, let's just do a simple example. Find the average rate of change of the function f of x equals 3x plus 2 on the interval 1, 2. So we have a formula. So by definition, let me use the notation I used before. The average value on the interval 1 to 2 of the function f is given by f of b minus f of a. So let me write it in symbols first, and then I'm going to use the actual numbers. So f of b minus f of a over b minus a. Now, in this case, our a is 1, right? So a is always the left endpoint of your interval, and b is 2, the right endpoint of your interval. So if I plug this in, this becomes f of b is f of 2 minus f of a is f of 1 over 2 minus 1. Okay. Now, plug in x equals 2 into this function. 2 times 3 is 6, plus 2 is 8. This is 8 minus, now plug in x equals 1. 3 times 1 is 3, plus 2 is 5. And divided by 2 minus 1 is just 1, and this is 3. So on average, you could say that this function changed by 3 units on the interval 1 to 2. Again, it's not the total change, but it's just a measurement or a sort of average of how much the function changed. Another example. Given the following graph of some function f of x, find the average value of the function on the interval -2 to 2. So what do you need? We know what the formula is. So we know what the formula is. Right? It's f of b minus f of a over b minus a. Right? And then we know what a and b are. Right? A is the left endpoint of your interval, in this case -2. B is the right endpoint. So now all we need is to know what f of b and f of a are. Right? So let me simplify this a little bit more. Right, so a is -2, b is 2. So this becomes f of 2 minus f of -2 over 2 minus -2. And then here you have to be careful. Remember that when you're subtracting from a number, a negative number, you have to include parentheses. Right? Because that way it's clear that the negative minus the negative is going to become a positive. So just a note of that. So we know what the denominator is. Right? That's pretty easy. 2 minus -2, minus is plus. So that becomes 2 plus 2. So we get 4. But now we need to figure out the numerator. We need to know what f of 2 and f of -2 are. Right? But we can use the graph to find what those are. Right? So at x equals -2, what's the function value? Right, so it's given here. You can either look at it at the graph, or I also give you the point. At x equals -2, the output is 2. That means that f of -2 is equal to 2. So we're going to have a -2, right, because the formula has a minus. Now what's f of b? Right, so b is equal to 2. And then what's the function value there? Again, you can just do it graphically, or I give you the point here. Right? At the input, x equals 2, the corresponding output is 3. right? So f of 2 is equal to 3. So numerator becomes 3 minus 2. If you simplify that, you get 1/4. So very easy. Once you have the formula written down, all you have to do is identify B, identify A, find f of B, and find f of A. If you're given the function value, you just plug in A and B into your function. If you're given the graph, use the graph of the function to find f of B and f of A, like we did here. Another example. Find the average value, or the average rate of change, sorry, of the function f of x equals 1 over x on the interval 1 to 1 plus h. Let me make a note here where h is greater than 0. So h here is a variable, right? And the idea is we're going to be using this later, right? Because it's going to be important for us, especially in calculus, to determine what happens when this h becomes smaller and smaller, right? So calculate the average rate of change of a function on an interval where the interval is becoming smaller and smaller. That's basically what the instantaneous rate of change is. But let's go ahead and do this. Again, we know what the formula is. Right, this is f of b minus f of a over b minus a. Again, a is always the left endpoint, so a is equal to 1. B is the right endpoint of the interval, which is 1 plus h. So let's simplify this. This is going to be f of b, that's f of 1 plus h, minus f of a, that's f of 1, all over b minus a, right? B is 1 plus h, minus a, which is 1. So we're going to need to find what f of 1 plus h and f of 1 are. Right? So f of 1 is very easy. Just plug in 1 for x. And then f of 1 plus h is also easy, right? A little bit harder, but still easy. Remember that whenever you have f of something, that means replace any x with that something. Right? So we saw that a couple of videos ago. So in this case, I have 1 over x, replace x by 1 plus h, so that becomes 1 over 1 plus h. Now, I can go ahead and plug everything in. Right, this is going to be f of 1 plus h, which is 1 over 1 plus h, minus f of 1, which is 1, all over 1 plus h minus 1. The 1's cancel, and you're just left with h. Okay. Now, I don't like to leave fractions like this, where I have a fraction minus a whole number. So I would recommend, just to make it look nicer and simpler, to combine any fractions. Right? So in this case, we want to combine 1 plus h, 1 over 1 plus h minus 1. You need to get a common denominator. So the common denominator is 1 plus h. Right. Notice that that's the same as 1. 1 plus h over 1 plus h is the same as 1. Now that you have the same denominator, you can subtract. And again, here we're subtracting all of 1 plus h. So make sure to use parentheses. So numerator is going to be 1 minus 1 plus h over 1 plus h, all divided by h. Simplify the numerator. 1 minus 1 plus h, 1 minus 1 cancel. Okay. Minus h, again, that's why it's important to keep the parentheses, so you remember to distribute the minus sign. So you're left with minus h over 1 plus h, all over h. And then if you remember your simplifying in algebra, right, this is the same as negative h times 1 over h. H in the numerator, h in the denominator cancel, and this ends up being negative 1 over 1 plus h. And this is why I recommend that you simplify expressions like this. See how the first time, where we just plug everything in, it looks a little bit messy, but after simplifying a little bit, it looks very simple. So that's why I recommend simplifying stuff like this. And that's basically it. This is the hardest type of problem that you're going to use that you're going to have to do in the homework for average rate of change. Now, again, the average rate of change is useful if you want to assign a sort of number to approximate the change of a function on an interval. Right? So for example, if your function defines revenue, and then your inputs are units sold or units produced, so you have a relationship between units produced and revenue. If you find the average rate of change of that function at an interval, you're kind of saying, okay, as my inputs or my the number of units produced changes from this value to this value, on average, my revenue is changing by this amount. Right. So it's a useful quantity to know. Again, geometrically, there's also other interpretations. It's the slope of a secant line. And then it's going to be useful later as well when you define instantaneous rate of change. Right? It's going to be related to this sort of definition here. So the average rate of change, the instantaneous rate of change is going to be defined similar to what I did here. Okay? You're going to see more of that in Calculus 1. And I might ask you a word problem on the written homework where you interpret the average rate of change of a function given a particular context.